So, open intervals and closed intervals, does that mean anything to you guys? The difference between this symbol and that symbol? Okay, here I don't include the endpoints, and here I include the endpoints, right? And you might say, well, what's the big deal about open interval or closed interval? We're going to see that it makes a difference. On Wednesday, we're really going to talk more about how do you find the maximum or minimum value on a closed interval. Okay? But what I do today will kind of lead into that. So, if the derivative is 0, that means the slope of the tangent line is 0. And what does that mean if I say that the slope is 0? You have a horizontal tangent line, right? So that makes sense that the only way that would happen is if you have a constant function, or at least you're constant on some interval. But we just said this. This is what you guys told me. Hey, if the derivative is positive, then the function is what? Increasing. If the derivative is negative, less than 0, then the function is decreasing. These are just key fundamental ideas. You know? And again, I think that a picture really says a lot about it, right? Here, derivative is positive. Here, f prime of x is positive. But in here, f prime of x is negative. Okay. Where do we have on this picture that the derivative is 0? Well, yeah. Right here at the top of this hill, right? There would be a horizontal tangent line. And down here at the bottom of this hill. In fact, the derivative equaling 0 is really a nice thing to have. Because if you think about it, what have we been talking about with a lot of these functions? Profit, average cost, okay, different things like that. Maybe the boss wants you to maximize this, right? So what do you want to maximize? Maybe you want to maximize your profit, right? Or maybe the boss says this, hey, tell me how much it could possibly cost me. You might maximize your costs when you're doing your calculation. Hey, this is worst case scenario, this is what it would cost. That's finding where the derivative is 0 can help you do that, okay? It's going to be called what's called a critical value. So, I want to teach today what's called the first derivative test. And I thought I'd use this as our first example, okay? The first derivative test. X e to the x. So I'm going to go ahead and give that a shot. It's a nice example because we were just dealing with this e to the x function all week. Well, for the last couple weeks, really. And so I'm going to go ahead and compute the derivative. Which means, what rule do I have to use to do this? The product rule, right? So remember the product rule, what we did was we called it u and v. And then what did we say the derivative would equal? Yep, u prime v plus times the derivative of v, right? So that's the process I'm going to use here to get the derivative. So when I do this, u prime would be what here? 1. And now it says v. Well, v is e to the x. Plus, and now where it says u, I'm going to write down x. And where it says v prime, what would I write down? E to the x. Okay. So that's nice. So now what I might do is simplify. Let's write down, remember I said before, we're not going to be simplifying. Well, now we're going to need to. So I get e to the x plus x times e to the x. Okay? And I'm actually going to do something else here in a moment. Let's comes back. I'm going to see if I can do anything else algebraically. What else can I do? Yeah, this e to the x can be factored out front, let's say. So you'd have e to the x times what? 1 plus x. Yeah. And so if you think about those slides that I showed you, if I want to know where the function is increasing, well, I look, where's the derivative positive? If I want to know where it's decreasing, I look, where's the derivative negative? But maybe even easier are to find what are going to be called critical values. Critical values, and I'll give you the definition. These are values in the domain of f, bless you, that make the derivative 0 or undefined. Now there's a word from algebra that we talked about earlier in the course, but it's been a few weeks, I think. The domain of f. When I talk about the domain, that's the set of all possible inputs, yeah? So here that we want to know the x values. I'll tell you, for this function, the domain is all real numbers. You could put any number you want in and put it in for x and take e to the x. Those are things you can do. Of course, by contrast, we just did log functions. Do you remember what the domain was for the log functions? What kind of numbers could you put into the logarithm function? Had to be greater than 0. Yeah, the domain there would be x is positive, right? So, anyways, here it's no big deal. It's any real number you want. But what I want to do is I want to find values that will make this derivative either 0 or undefined. Well, it turns out that to make it 0, you basically have to solve this equation, right? 0 equals e to the x times 1 plus x. Now you can see why I factored it. That just makes it easier to solve because we know that either e to the x equals 0 or 1 plus x equals 0. That's how factoring works when you have something set equal to 0. Now, can this happen? E to the x equals 0? No, we know that e to the x is always positive, right? I mean, think about what the graph looks like of e to the x kind of takes off, right? Exponential growth. And you have an asymptote here, but it's never going to be negative, right? But how about this one? We get x equals what? Okay, x equals -1. So what did I learn? Well, not much yet. I guess I learned that if I put a -1 in for x, the derivative there is 0. Right? And so now let me explain the first derivative test, or demonstrate it. When you do the first derivative test, here's what you do. You compute the critical values. As defined above. That's step 1. Step 2, draw the intervals between these critical values and use what's called a test point to determine if the function is increasing or decreasing. Exactly what we were doing in that section project. Okay? And that's really the process. So let me go ahead and demonstrate it on the side. I just figured out that I have a critical value at x equals negative 1. Remember, we said that x is allowed to be any real number, really from negative infinity to positive infinity, right? So what I'm going to do is I'm going to draw negative 1, and that's a critical value. I know that f prime of negative 1 is 0. F prime of negative 1 is 0. So now what you need to do is you need to look at the intervals. We have from negative infinity to negative 1, and we also have from negative 1 to positive infinity, right? And what I'm going to do is I'm going to pick a test point. So you could pick any number you want between negative infinity and negative 1. So let me have one. What would you pick? Negative 10, negative 2, doesn't really matter. But what we're going to do then, say I use negative 10, that was suggested first, right? That's called a test point. I'm going to compute f prime of negative 10. Well, I better write down what I had. I had f prime of x was e to the x times 1 plus x, right? It's actually really nice if it's factored like this. So when I go to do f prime of negative 10, I get e to the negative 10 times 1 plus negative 10. You guys with me? And I don't care what e to the negative 10 equals. Don't put that in your calculator. That's huge. Actually, e to the negative 10 is really small. Because you remember what e to the negative 10 means? It means 1 over what? E to the 10. Here's my question to you guys. This thing here, is this positive or negative? This e to the negative 10 is really a positive number. Are you guys clear on that? What about the next number? 1 plus negative 10. Is that positive or negative? That's negative, right? So what did I learn? I learned that f prime of negative 10 is what? Well, it's a positive times a negative. So it has to be what? You guys agree? Negative. What does that mean about the original function? It's decreasing. So we know that the function is decreasing on this interval. Negative 1. Negative infinity up to negative 1. If you try negative 2, you're going to get the exact same thing. You get a positive times a negative. Here, let's pick a number between negative 1 and infinity. 0. That's a nice example. So, let's see. F prime of 0 would be e to the 0 times 1 plus 0. What's e to the 0? 1. What's 1 plus 0? 1. What's 1 times 1? I love when I get to say that in calculus, you know. But I don't even care what it equals. All I care is that it's positive. If it's positive, the derivative is positive. What does that tell me about the original function? The original function is increasing. You guys see that? So what did I learn? I learned that the original function is decreasing until it gets to negative 1. And now I learned it's increasing from negative 1 to positive infinity. Okay? So let me give you one more step. Step 3. determine whether or not there are, and I'm going to give you the word, relative extrema at the critical values. Here's the deal, guys. I'm telling you that the function is decreasing until it gets to -1, and from there on out, it's increasing. And when I say relative extrema, there's two kinds. You could have a relative maximum or a relative minimum. And what I mean is, the biggest thing around would be the relative maximum. The smallest thing around is a relative minimum. What would you tell me at -1? It's called a relative minimum, right? Because we know we're decreasing until we get to -1. Then we're increasing. And so in this example, we're going to see we have a relative minimum at x equals -1. And I just want to show you, I did a graph of this function, x times e to the x, using the computer. And I just want to show you what it looks like, and then I'll take questions, okay? There's the function, right? Here it is decreasing until it got right here to -1, and now it's increasing. So we call that a relative minimum right there. You guys see that? Okay. When you say at -1, we're at 0, it doesn't look like it from the picture, right? What is it that's 0 when you put in x equals -1? This is something that we'll have to keep track of, right? The original function is what I just graphed, x e to the x, right? But the derivative, yeah, when you put in -1, the derivative is 0. Does that make sense? I mean, that's a great question. What's the value of f of -1? Well, I guess it would be negative e to the -1, -1 over e, whatever that equals. Actually, I could tell you what it equals. Yeah, let's about -1/2, right? I mean, if I want to know the exact value, I could put that in, right? I could say, hey, what is -1 divided by e? So it's -0.3. But when you look at the picture of the graph, yeah, okay, that's as low as it'll go. From there on out, it's going to be increasing.
How do you know if, how would you know to graph that? Can you know?
Oh yeah, so I'm here graphing it, right? But I'm telling you that the calculus can tell you what's happening whether you have a graph or not, if you follow this procedure.
You get that, but you have to do a lot of test points to know where.
Well, we had to do 2 test points, right? It turns out that if you just test each interval once, you'll get everything. You got to get a test point from each interval.
You know if it's increasing or decreasing, I'm saying the rate.
Oh yeah, that you don't know, the rate.
Okay.
Yeah, that you don't know. All you know is increasing or decreasing. It doesn't tell you the whole story yet. That's a good point. All right, so let's go back to another example here. Well, here's 2 more examples that I'd like to do with you, and then I'm going to turn you guys loose on a group work, I think, for the end of class, okay? But I'd like to do these 2 examples because they kind of are a little bit different. So the first one I have the function x cubed minus 12x. And then the second function, so that's a rational function, I have g of x is x squared over x squared minus 1. So I'd like to do the first derivative test on both of these for you so you kind of have a couple more examples to work with before you try it. So we're going to take a derivative, right? So we do. We say, well, f prime of x equals 3x squared minus 12. Okay? What I'd like to do next is I'd like to find the critical values. Now, critical values are things that make the derivative either 0 or what? Or undefined. This is a polynomial, guys. It's not going to be undefined. All you're going to have to do for this example is just set the derivative equal to 0. All right? It might be a little bit tougher in the next example. We'll see. But I set the derivative equal to 0. How do I solve? Well, probably add 12. Divide by 3. Okay. Yep, take the square root. When you take the square root, you have to remember something. So what are the critical values? Plus or minus 2. Okay. So now if you want to do the first derivative test, here's what you do. You draw the number line, the entire domain. What's the domain of my original function? All real numbers. That's a polynomial. I put the critical values there. So how many intervals will I have to take test points from? 3 different intervals, right? You better take something smaller than -2, something between -2 and 2, and then something bigger than 2. And when you try out the test points, you're using the derivative, f prime of x, right? Now, by the way, I'm going to do something I did last time. I'm going to factor it. Sometimes that makes all the calculations a little bit easier. Matter of fact, can you factor it anymore besides taking the 3 out? 3 times, well, x minus 2 and also x plus 2, right? I mean, you may have already done that to solve it. I don't know how you solved it. You could have solved it the way we did, or you do it this way. But now, if this is f prime of x, now when you try different test points, it makes the calculations simple. All right? So what test points should I use? Okay, -3 I'll use. What else? 0 and 1, okay. Oh, or 1. And how about I use 7, right? I mean, it doesn't really matter. But when I do these things now, I can go ahead and fill some things out. So f prime of -3 would be 3 times, how about I just write negative, right? -3 minus 2. What about -3 plus 2? Is that going to be negative or positive? So I have 3 times a negative number times another negative number. So is it going to be negative or positive?
Positive.
Because 2 negatives makes a positive, right? So you know what I just learned? I learned that this function is increasing here. Let me try f prime of 0. Well, that's 3 times 0 minus 2 times 0 plus 2. So that's 3 times negative times positive. So what's that going to be?
Negative.
Yep. Right? I have 1 negative. So what are we going to be doing from here to here? Decreasing. And now, once we're greater than 2, let's try f prime of 7, I said. That's 3 times 7 minus 2 times 7 plus 2. Again, I don't really care when I do the first derivative test what these things equal. All I care is I know that it's positive. And that tells me that my function is going to be increasing once we get past that value there. Okay? So the last thing I want to do is I want to talk about where we might have a relative minimum or a relative maximum. Okay? So let's see. Can you think of a place that I might have a relative minimum? At x equals 2. I agree, because it was decreasing and now it's increasing. And how about if we have a relative maximum? Yeah. Now, by the way, you don't have to. Here's a question you might ask. Do you always have a relative maximum or a relative minimum at a critical value? And the answer is no. You're going to find when you do the homework tonight, there will be times that you do the derivative test, and maybe what you get looks like this. Maybe you'll have some intervals. What if they were positive, 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 or something like that? Well, then it's always doing what? Increasing. So you're not going to get a relative maximum or minimum in that situation. That can happen. Okay? But this kind of situation is one that gives you an example of each. We had a relative minimum and we had a relative maximum.
The first example, we only had a relative minimum.
Right. The first example, we only had a relative minimum. No maximum. Matter of fact, the first example, you get that exponential growth when you move off to the right. It really takes off. So there is no maximum value at all. All right, so I wanted to do one more example where things are a little trickier about function g here. I mean, one thing that's different is that right away, when you get a function like g, you have to ask about the domain. And so I'm going to pause here for a moment and let you guys talk that out. I mean, what can you tell each other about the domain of g? When I try to think about the domain, I don't think about what x can equal. I say, well, is there anything x can't equal? I know that,
One.
yeah, because this denominator, right, is not allowed to equal 0. So x squared minus 1 is not allowed to be 0, right? So really you're solving an equation, but I put a not equals there instead. And by the way, not only 1, there's another thing it can't equal, right? If you factor it, you'll see that. X plus 1 times x minus 1 is not allowed to be 0. So the domain, I don't know how you guys are going to do this. If you use interval notation, this is the way we did it, say, in a college algebra class. We used to say from negative infinity to negative 1, from negative 1 to positive 1, and then you union that with 1 to infinity. So some of you are very familiar with that notation. Some of you would just write down, hey, x is not allowed to equal 1, and x is not allowed to equal negative 1. I don't care. But for a problem like this, it's important to understand the domain. And I'll show you why. Because what happens is, first thing I say is okay, guys, we want to find the critical values. Maybe I'm interested in what's the maximum value of g? I don't know. But if I know that if I want to find a relative maximum, I can at least start by looking at the critical values. So maybe the first thing I'll do is I'll compute g prime of x. So maybe I should pause and let you do that. What rule are you going to have to do for this? Quotient rule? All right. Let's let you work, guys. You guys all did this derivative. Let's see. So you did Hody high. So you did x squared minus 1 times 2x, right? And then you subtract Heidi ho. So x squared times, what's the derivative of the bottom? Well, that's 2x also, right? All over. And then we get x squared minus 1 squared. So that's kind of interesting because what you get for g prime of x, let's see, you get, if I distribute here, I get 2x cubed minus 2x minus 2x cubed all over the x squared minus 1 squared. So it looks to me like g prime of x is equal to negative 2x over x squared minus 1 squared. Okay? Now that's a pretty ugly derivative. It's a rational function. And I'm trying to find what are called critical values. So I ask myself two questions. Is there anything I could put in for x that would make this equal to 0? Or is there anything that I could put in for x that would make this undefined? Now we know if you put in a 1, what's going to happen? Well, it's going to be 0 or undefined. Okay? To make a fraction undefined, you make the denominator equal to 0. So I'm going to say this. 1 or negative 1 would make g prime of x undefined. But these are not in the domain of G, right? We said that at the beginning. So they are not critical values. Okay? Now, is there any way to make g prime of x equal to 0? How do you make a fraction equal to 0? You make the numerator equal to 0, right? So you're right. I mean, basically, I look at that, and I say negative 2x has to equal 0. So x equals 0 is a critical value. Okay. So I'm going to go to the next page here because I'm going to need a little more room to kind of finish up what I want to do. Okay, let's go through this again. We had g of x from the last page, and we just computed g prime of x was negative 2x over x plus 1 squared. G of x was what, x squared over x plus 1? No. Oh yeah, x squared minus 1 on the bottom. This is x squared minus 1 squared on the bottom. And my numerator was what? X squared, right? So there's the original function. There's the derivative. We found out from this x equals 0 is a critical value. Okay, so now I'm ready for the first derivative test. Go ahead and write out that number line. Right? Because you make the numerator equal to 0. Right? So if I plug in a 0, notice g prime of 0 would make the numerator 0. It equals 0. Right? 0 over 1. That's why. Critical values are things that make it undefined or equal to 0. Right? Guys with me? So now what am I going to put on the number line? Well, you want to put important points, right? So I'm going to put my critical value. I'm going to put 0. But I'm also going to put values that were undefined, right? So I'm going to put 1 and negative 1 because these are, g of x is undefined here. And same here, g of x is undefined. So there's actually a little more work to do here. We have to go through. We have to pick a test point for this interval. We have to pick a test point for that interval. We have to pick a test point for that interval. We have to pick a test point for that interval. Okay? And we want to plug them into G. In between the undefined, that's right. Because things could change. Yeah.
Negative 4?
Negative 4 is a great one, yeah. And before I do it, here, I'm going to do negative 4 like you suggested, Joe. But before I do it, let me rewrite, where am I going to be putting those in? Into G or into G prime? Into G prime. So when we do, for example, let's test negative 4, right? This is called the first derivative test. G prime of negative 4 would be negative 2 times negative 4 over, wow, this is ugly. It's negative 4 squared minus 1 squared. That's really ugly. Luckily, I don't have to compute it. All I care is what? Is it negative or positive? Okay, so let me work it out. How about the numerator? I have a negative times a negative. So what's that going to be? It's positive, right? How about the denominator? Is the denominator going to be positive or negative? You know it's... How do you know it has to be positive? Yeah, go ahead, Crystal. Yeah, the exponent there, we have a 2 there. We're squaring it. Any even exponent, you're going to have a positive value, right? So the whole thing then, if I have a negative times a negative over a positive, what would you tell me? Okay, so that means that this function is increasing here. Do you guys understand? I need a value between negative 1 and 0 now. Well, I guess, yeah, negative a half. And again, I'm going to try G prime of x. So let me work it out over here. G prime of negative 1 half would be negative 2 times negative 1 half over, how about I just say over positive, right? It's going to be positive there, right? So what happens between negative 1 and negative 1 half? It's still increasing. It's still increasing. Now, if you try G prime of positive 1 half, that's going to be negative 2 times positive 1 half over a positive number. And so what's that going to be? Negative, which means what? Now we're decreasing. And let me tell you that this is going to be decreasing also, because I don't want to work it all out. What I'd like to do is draw a picture of g of x with a calculator so you can understand the relationship between what we just did and what we see on the calculator. Holy mackerel, that's not my calculator. Let's try it again over here. There we go. So let's type in to the y equals screen. Clear that out. We need just x squared. And then, oh, no, that's not squared. I'll do x caret 2 divided by, and now I want x squared minus 1 in parentheses. Okay. I'm going to press zoom standard. You know, I realize today I'm not doing very much applied, am I? I'm doing a lot of just basic math examples, but I think it's important for you to see this. Look at that graph. Here, maybe we'll learn a little more if we zoom in. Okay. Those vertical lines, remember what those are? Those are asymptotes. We knew we'd have a couple of asymptotes. Look at the picture. We're increasing until we get to the asymptote. We're increasing until we get to 0. Now we're decreasing, and we're also decreasing over here. Do we have any relative extrema for this problem? What kind? We have a relative maximum. Where? Now, is that really a global maximum? Is it a maximum of everything? No. The output's 0, right? This function goes through 0, 0. But it's a relative maximum, means it's the biggest thing around in a neighborhood of 0. You guys understand? Yeah, when I say a relative maximum, what I'm saying is that if I go on either side of 0, I'm going to be going down a little bit, right? Because it increases up to 0 and decreases down from 0. Now, as I look at that picture, there's definitely points that are higher than 0, 0. But as far as when you're near x equals 0, it's the biggest thing around. It's a relative maximum. Okay? And we're going to talk more about that on Wednesday, actually, when we get into this, some of those ideas a little bit more. All right. I think I'd like to close out with a little group work. I do not think we have time to finish.